All right, so the next problem is problem 5-29. So let's go ahead and see if we can find it here. Actually, I think it's in a different learning goal. So yeah, there's no 529 here. So let's X out of there. We'll just close this out. And we will drop down to learning goal 4. And there's problem 529 right there. Okay. And most certainly going to need a financial calculator for this problem. So let's pull the calculator back up. And I'm going to just minimize it and share the screen. All right, so for this problem, we have essentially a mixed stream problem. So we have Gina has contracted to sell a small parcel of land that she's inherited. She has a buyer that's willing to pay $23,170 at the closing of the transaction, or will pay the amounts in the table. So she's either going to pay, that being the buyer, a lump sum now, or pay this mixed stream of cash flows over the course of 5 years. So we want to find out which one is essentially more valuable to Gina. And these mixed streams are going to be paid at the beginning of each of the next 5 years. And she doesn't really need the money today, that being Gina, so she plans to let it accumulate in an account that earns 8% annual interest. And given her desire to buy a house at the end of 5 years after closing on the sale of the lot, she decides to choose the payment alternative, either the single amount or the mixed stream, that provides the higher future value at the end of 5 years. So which alternative will she choose? So this is a little bit more of a complicated problem than most of the time value money problems that you're going to see, but certainly something very doable within the financial calculator. And so the first task is to find out the future value of the lump sum deposit. So again, if one of the options is for the buyer to simply pay $23,170 at closing, so let's put that in here as our present value. So $23,170 is our present value. That's how much that we would receive right now. And if Gina goes with that option, it's going to sit in an account for 5 years, because that's her time frame for when she wants to buy a house in the future. So let's put 5 as our N. And again, just running with things that we know already. So when that money sits in the account, it's going to earn interest at an assumed interest rate of 8% annually. So let's put 8 as our N. 8 as our I. So 8 is our interest rate, annual interest rate. Nothing that we need to do with payment, because we're just looking at the future value of a lump sum. And so all we need to do is just compute for future value. And so in this case, we have a future value of $34,044.33. Let's check that. And we're good there. All right, and the second part of the problem is definitely a little bit more of a complicated problem for time value of money. And the reason is because we're using the cash flow register, or we have a mixed stream that we can use the cash flow register for, which isn't necessarily the hard part, but the complication is that we are looking for a future value and not a net present value. So typically with the cash flow register, which is here, this CF cash flow button here, is how we will organize our mixed streams and complete the problem much more quickly than if we were to do individual future value problems essentially 5 times. So we could do 5 future value problems here and then add up the sums in order to get our final answer, or just enter them much more quickly within the cash flow register. But again, the cash flow register is set up to find the net present value of a mixed stream. And what we need to find is the future value. So not a big deal, but we do have to essentially do this in 2 steps. So let's clear this out. So we use this C/CE button to clear the line here. And actually, let's go ahead and just reset the whole calculator, and we'll start from scratch. So one thing I like to do with the cash flow register is enter the interest rate first. So on your handheld calculator, you'll actually enter the interest rate last. It's really the last step before you hit compute to find the present value of a stream of cash flows. On the online calculator, which you certainly have access to, The easiest way, in my opinion, is just to enter the interest rate first. So what we do is just enter 8, still our required rate of return for this problem. So we'll enter 8, put it in the interest button here within the 5-key method, even though we're using the cash flow register. If you click on that, it's see here on the screen, and then when you hit the cash flow button here, it just carries the rate up to the top. So you can enter the rate or change the rate while you're in the cash flow register. That's fine, but to me, just as a best practice, more efficient just to enter the rate first, hit the cash flow button, it just carries it into the cash flow register, and then you're off and running. So we don't need a cash flow 0 because there's no upfront cost for this stream of cash flows. We will start using cash flow at time 0 or upfront costs when we get into capital budgeting problems in chapter 10. So for this problem, and many like it in chapter 5, we can just simply arrow down to our first cash flow. So cash flow 1 is 2,000 in the problem, so we'll enter 2,000. And then hit the enter button after that. So press enter, and you can see it populates up here. Arrow down to frequency, so F1 means frequency 1. So this $2,000 happens just one time, so frequency 1 is just 1 as it already assumes. We arrow down again, and the second cash flow is 8,000, so we enter 8,000. Arrow down, it's a one-time cash flow, so we just leave frequency 2 as 1. Cash flow 3 is 4,000, so we enter that, and arrow down again. Notice here up at the top that it's great to have the numbers in the screen so you can make sure you can double check your answers, make sure there's not or double check your inputs, I should say, and make sure there wasn't a miskey in here. But note that it's not going to match as far as cash flows go. So remember, cash flow at time 0 is really the first number that we could have input something. So our first cash flow is $2,000. Here it's listed as the second number. That's fine, don't worry about that, but just understand that it's not going to match exactly your cash inflows that you're putting in now. So as long as you're up here in the correct order, that's what really matters. So the third frequency is still 1, so $4,000 is the year 3 cash flow. So we'll just arrow down again, and the fourth cash flow is $8,000, and enter that. Just one-time cash flow, so we'll leave frequency 4 as 1. Arrow down again, the fifth cash flow is 7,000, and enter that. Arrow down, and now we're essentially done with the input. So we'll leave the frequency 5 as 1 as well, because all the cash flows are unique. They're not repeating in any of the consecutive years. So all we need to do now is just compute net present value. So this is what you'll do for most of the mixed stream problems that you'll see, because most of the time you're going to find a present value, and certainly in chapter 10 you'll find a lot of net present values calculated with an upfront cash flow as well. In this case, though, we have the net present value of a mixed stream of cash flows, but what we really want is the future value of this stream. So that's not a problem. So we're going to note down that the amount is $22,530 and 21 cents. That becomes our present value of the mixed stream that we can use now in the 5-key approach. So we did the cash flow register to solve the mixed stream for the present value, so that eliminates the need to have to do 5 separate lump sum time value of money problems to figure out the future value of each of these cash flows, and then add up the total to find your final answer. But we're going to do it. We're going to do the same thing. We're just doing it in a 2-step process that's still faster than doing 5 different single lump sum problems. So what we can do is just reset. And now that 22,000 that I just wrote down, I'm just going to copy it back in here. 22,530 and 21 cents becomes our present value. And we're still assuming an 8% interest rate. So now we're in the 5-key approach, taking the present value of this mixed stream and just solving it for the future value, which is what the question asks for. So what we're going to do is we're going to compute for future value. But what we're missing one thing. We're missing the n. And here's where you can get tripped up pretty easily. So we have 5 years of data, and 5 years is what Gina is concerned about as far as being able to buy a house at that period of time. But remember, so if the payments were received at the end of the year, at the end of each year, then we would just use 5 because it would be essentially, it would be 5 years. But since the payments are being received at the beginning of each year, that's really giving us 1 extra year for interest to accrue because we're receiving the payments at the beginning of the year, and now they have the full year to accrue interest as opposed to receiving the payments at the end of the year. So the way to account for that is just simply add 1 to the number of years. So we're going to use 6 as the n. Okay, so once again, if you were working a problem, which you'll see at least one problem, where you'll have beginning versus end of year mixed streams, if it was going to be paid out at the end of each year, you would just have used 5n. Okay, because you're waiting the whole year to receive the payment. But since the payments are being received at the beginning of the year, we're getting the benefit of an extra year's worth of interest. So we're going to use 6 as the n. And we're going to then compute for future value. Okay, so the future value of this stream of cash flows is the $35,752.61. And let's check that. Okay. And then the final answer is just asking which alternative will Gina choose. And she's going to choose the one, economically, theoretically speaking, she's going to choose the one that has a higher value based on the assumptions that we're using, which are interest rate primarily. So she's going to choose the mixed stream in this case.